Good day, everyone. My name is Engineer Shegun, and you are welcome back to WAEC class. Today, we'll be discussing static electricity. Now, from the name, we can already get the concept of what static electricity is all about. Static electricity is basically the study of charges at rest. There is a fundamental law of electrostatics, and the fundamental law of electrostatics states that like charges will repel and unlike charges will attract. There are two types of charges in nature, positive and negative. Now, in order to understand the force of attraction or the force of repulsion between these charges, I'll further introduce you to Coulomb's law. Coulomb's law. Coulomb's law states that the force of attraction or repulsion between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of their distance apart. This whole statement I just made can be expressed mathematically as such. F directly proportional to Q1, Q2, R squared, inversely proportional to R squared. So from this expression, I can note that the force is directly proportional to Q1 and Q2, where Q1 and Q2 are the point charges. Q1, Q2, of course, is the product of the point charges, and this is the square of their distance apart. I can decide to introduce a constant, and if I do that, I'm going to have F is equals to K, Q1, Q2 over R squared, where K is now our Coulomb's constant. K itself is equals to 1 over 4 pi E naught. So if K is equals to 1 over 4 pi E naught, I can rewrite this whole equation as F is equals to Q1, Q2 over 4 pi E naught R squared. Now this is Coulomb's law. The value of K itself is 9 times 10 raised power 9 Newton meter squared per Coulomb squared. And E naught here is the permittivity of free space. The next thing we talk about is electric field. Electric field is a region or space around a charge where the influence of the force of the charge is detected or felt. The electric field intensity or the electric field strength at a point in an electric field can be defined as the force per unit charge. So mathematically, I can say that electric field strength or electric field intensity is equals to force divided by charge. Now, we are going to take questions from Coulomb's law down to electric field intensity. Now, question number 1 on static electricity. In this question, we have the force of repulsion between 2 points positive charges, 5 microcoulomb and 8 microcoulomb, separated at a distance of 0.02 meters apart, is, they are asking us for the force of repulsion. Now, they said that they are positive charges because obviously I can see no negative sign here. That means the sign here is positive. And this symbol means micro. So microcoulomb, this is 5 microcoulomb and this is 8 microcoulomb. The unit of measuring charge is in coulomb, not in microcoulomb. So it will be important that I have to convert this microcoulomb to coulomb and then this microcoulomb to coulomb. Our formula obviously will be F is equals to K, Q1, Q2 over R squared. We are given our distance apart at 0.02 meters. Now, but the question did not give us K directly. Look at what they said that is very interesting. 1 over 4 pi E naught is equal to 9 times 10 raised power 9 Newton meter squared per Coulomb squared. Recall earlier on, I told you that K itself is also 1 over 4 pi E naught. So by them saying 1 over 4 pi E naught, they are giving me K. This is K. So therefore, my K is 9 times 10 raised power 9 Newton meter squared per Coulomb squared. I can now put in my values. I can then say F is equals to 9 times 10 raised power 9 times the first charge there is 5 microcoulomb. 5. Remember, it is in microcoulomb, so I need to convert it to coulomb. How will I convert it to coulomb? By multiplying by 10 raised power minus 6. So times 10 raised power minus 6 times, there is 8 microcoulomb. 8, convert it to coulomb, times 10 raised power minus 6, all divided by, the distance apart is 0.02 meters. But remember, our formula is r squared, that is the distance apart squared, the square of the distance apart. So I would then say 0.02 all squared. Now, all we have to do is to break down. If you are a white student, you will not have too much of a problem here. But if you are a JAMB student, the calculator that they are going to give you will not be a scientific calculator. So you need to know how to work around this without a scientific calculator. They will just give you a basic calculator. Now, how do we do that? Simple. I can simply do 9 times 5 times 8. Alright? Now, if I do all of this, and by the way, this 0.02, I can do it as, by the way, 9 times 8 is already 72. 72 times 5, that will give me 350. I think 350. If I do 72 times 5, I will have 72 times 5. Obviously, this is 10, to that 0 carry 1. This is 35, plus that one, 360. So that's going to give me 360. 360, then this is 10, this is 10, and this is 10. I'll pick one of the 10 from indices 10, 10, 10. I'll pick one of them. If I pick one of the 10, then I'll add up their powers. If I add up the power, I'm going to have 9 minus 6 minus 6. Recently, I say 9 minus 12. And that should give me minus 3. Divided by, the power, this is 0.02, all squared. I can also do it as 2 times 10, 1, 2. Raised by minus 2, all squared. Which I can go on and say, this is 360 times 10 raised by minus 3, divided by this square is going to affect both these 2 and then this 10, which will give me 4 times 10 raised by minus 4. Now, from here, this whole stuff is going to be 4 into 360. 4 will go into 360 90 times 10. I can now work on these powers. This is raised by minus 3, this is raised by minus 4. This is the same thing as saying minus 3 minus 4. From here, I will have 90 times 10 raised by minus 3 plus 4. And that should give me, minus 3 plus 4 will give me 1, 10 raised by 1. So I'm having 90 times 10, which is something as saying 900. 900 is something as saying 9 times 10 raised to power 2 Newton. This is our answer. 9 times 10 raised to power 2 Newton. And that will be option C. Let's take our next question. Question number 2 on electrostatics. If the distance between stationary charged particles is doubled, the magnitude of the electrostatic force between them will. So in this question, it's not based on numbers. They are just trying to ask us a concept. We are going to calculate, but no numbers here. First, they didn't say anything about the initial force. So let's just call our initial force F. So we call it F, or F1 is equals to F. That's our first force. They're not saying that if the distance is doubled, meaning that if my first distance R1 is R, my second distance R2 will be 2R. What will be the new force? That is F2. I don't know. All the formulas I've given so far, I've never given a formula that has 2 force on it. So when you're wondering what kind of formula am I going to use here, you can use what I've already given you, and this is the way you can get out the equation that you need from what I've given you in the past. You already know that F is equals to K Q1 Q2 over R squared. Now the question is more concerned about the force and distance, not the charges. So I can break everything down to saying that whole stuff here, KQ1, KQ2 is a constant. Why would I call it a constant here? Because they didn't change the charges. All they did was to change the distance. So I can treat everything as one huge constant. If I do that, I will have F to be equal to, let's call it constant C over R squared. Now if I cross multiply, I'm going to have F1, I'm going to have F R squared is equal to C is my constant. It's a basic law in mathematics that if I have AB is equal to constant C, then I can say A1 B1 is equal to A2 B2. This is a basic law in mathematics. So therefore, if I have F R squared is equal to C, then I can say that F1 R squared 1 is equal to F2 R squared 2. Now you can consider this as a new equation, but I would not want a student to memorize this. You can always get it from here, anytime, any day. So doing this, I'm looking for F2, then I'll make F2 subject to formula. If I make F2 subject to formula, I'm going to have F2 to be equal to F1 R squared 1 over R squared 2. Now let's move over to this side. Recall that F2 will now be equal to, our F1 is just F. Our R1 is just R, but that is R1, that is R1 squared here. So I'll just write R squared over. Remember that our R2 is 2R, and I'm having R2 squared here. R2 is 2R, and I'm having R squared here, which means I will say 2R all squared. I'm going to square everything. Now, getting to this place, I will have F2 to be equal to FR squared. This square here is going to affect both this 2 and this R. It's a basic law in mathematics. So here, I'm going to have 4R squared. This is R, this is R. They will both cancel out. So I'll have F2 to be equal to F over 4. What does this tell us? It is telling us that the final force or the new force is now a quarter of the initial force. Now let's check our option. Half? No, that is not half. Double? No, that is not double. A quarter? Yes, it is a quarter. 1 over 4, a quarter of the initial force. D, unchanged. It's E, 4 times the original value. So the appropriate answer from what we got is C. Now, the next thing we want to look at is to dive deeper into some other concepts in electrostatics in our next class.